So after today, you should be able to go through and complete all of chapter 12 homework. We'll have learned everything. Here we go. So this is the same, we're just building off of what we did last time, okay? But now our carbons are in a ring. So we still have a prefix. This tells us where the substituents are. If there's more than two, we'll use numbers. And then we add this between our prefixes and our parent compound. We're going to use cyclo. That tells us that our carbons are in a ring. Okay. And we're going to name the parent based on how many, let's see, where did that go? Based on how many carbons are in our ring. So we still have our, does anyone need the chapter 12 handout? Okay. So we're just going to use these names still. So if I have 5 carbons in a ring, that's going to be called cyclopentane. If I have 3 carbons in a ring, that's going to be cyclopropane. I can't have 2 carbons in a ring, so we can't have cycloethane or methane. So we just count up the carbons, name the parent. If the carbons are in a ring, that's cyclo. And then our suffix for this chapter is just ane. Okay, that means that there's no double bonds, there's no triple bonds, there's no other functional groups. So just boring, we use ane at the end. Okay, so the only new thing today is that we're going to talk about this cyclo. What do we do if the carbons are in a ring? So this is an example. If we count up our corners in this ring, 1, 2, 3, 4, 5, 6, we have 6. So our prefix is hex. This is hexane, okay, with 2 different substituents. So if we were looking at this, what is this substituent? Oops, it told us. Where are we? What is this substituent?
Methyl.
Good, this is a methyl group. How about this one?
And ethyl.
Good, methyl and ethyl. Good. So we're going to count the carbons in the ring for our parent name. We're going to use the prefix cyclo. If it's cyclooctane, you keep both of the O's. I think that came up once for me. So just keep all the letters. All right, if we only have one substituent, so if we only have a methyl group, then we don't need to tell you where it is. We don't need a number. It doesn't really matter because if I turn it, it's the same molecule, okay? So this would be methyl cyclohexane, and this one we have 4 carbons here. So we have butyl cyclo. We have 1, 2, 3, 4, 5 in a ring. So our parent is cyclopentane with a butyl group. Okay, questions on that? Does that make sense? Okay, so if we just have one, no numbers. If we have more than one, then we're going to figure out which one should go first. We pick one of them, and then we try to make the sum of the numbers the smallest. So we want the least number for our substituents, okay? The least locations. Least number for the locations. Let's see. If we have more than one substituent, then we're going, all of them, so if we have like 3 substituents, then all of them have equal opportunity to be the first one. So they all have the same priority. That's what I'm looking for. And so it doesn't matter which one you start with as long as the numbers of the substituents is the lowest it can be. Okay? And then if you just have 2 different substituents, then you're going to pick number 1 to be the one that is alphabetically first. So we'll look at some of these examples. So if there's just 2, then we worry about alphabetical. If there's 3 or more, then we care about lowest number. Also with alphabetically, we also care with lowest number, but that helps us pick which one's first. So kind of like last time, just a little bit different because it's a ring. So let's look at some examples, and then there's one to practice. So here we have two methyl groups. So we have two of the same group. We just want to lower the numbers of the substituents. So it doesn't matter which one I pick. If I pick this one to be 1, I'm going to go 1, 2, 3. So this one's a low number, this one's a low number. If I go the other way, 1, 2, 3, 4, 5, then my substituents are a higher number overall. And we can also add them. So if we do 1 plus 3, that gives us 4. If I numbered the other way, 1, 2, 3, 4, 5, 1 plus 5 is 6. So that would be wrong because I didn't reduce the substituents number. Okay. And then we tell, in the name we say there's 1, 3 because they're at 1 and 3. And then there's 2 methyls, so we use dimethyl. And then there's a circle, so it's cyclohexane. Okay, so then if we have two different groups, only 2 different groups, then we're going to pick number 1 as the one that comes first in the alphabet. So we have an ethyl group, and we have a methyl group. Ethyl comes first, so we're going to say number 1, and then we're going to go so that the methyl group has the lowest number. So we're going to go this way instead of going all the way around. Okay. And so then we would have 1 ethyl, 3 methyl. It's a cyclic carbon cyclohexane. Okay, I'll do some examples. And then I have 1 practice problem. 2 examples and 1 practice problem. Okay, so the first thing that I'm going to do is I'm going to look at the carbon ring. And I'm going to see how many there are. So I see, let me turn my pen on if I don't think it's on. I'm going to count. Here's 1, 2, 3, 4, 5, 6. So this definitely has 6 carbons. So what am I going to call the parent? Good, it's going to be hexane. And then it's in a ring, so it's cyclo. No space, cyclohexane. And then what kind of groups do I have here? Good, these are 2 carbon groups, 1, 2, 1, 2, 1, 2. So these are all ethyl, so I'm going to say triethyl. No space between those. And then I have to decide what is the best way to number this. So I did it like this, 1, 2, 3, 4. So if I added up, I have an ethyl at 1, I have an ethyl at 3, and I have an ethyl at 4. This gives us 8. Okay, so let's try a different numbering system. We'll try it in blue. So the other way there's many ways actually, but let me show you another way that probably works a little bit better. So 1, 2, 3, 4, 5, 6. So if I add that up, I have 1 plus 2 plus 4. So that's going to be 7. So that reduced the total number of the substituents. Okay. So I want to go with this one because it reduces the number. We can try other ways, but this is going to be the smallest. Okay. There's lots of ways you can number this. So I'm going to call this 1, 2, 4, and then between things that are not the same, we put a dash. 1, 2, 4 triethyl cyclohexane. Okay. All right. So good. All right. Here's one more example, and then there's a practice problem. So let me show you how we do this one. So we have the same parent. So we have cyclohexane. Okay. Now we have 3 substituents. So they all have equal priority of being first. So we just want to number them so that we have overall the smallest number. So we could go 1, 2, 3, 4. Okay, so that's going to be our best way. We could try to go backwards, but then we'll have 2 at a higher number. So this is going to give us the smallest number. So then I need to start with chlorine because it comes first. So we have a chloro group and then we have two methyl groups, but chloro comes before methyl. So this is 2-chloro. That's where chloro is. If it's a chlorine, then we call it chloro in the name. And then we have a dash between a letter and a number. I'm going to say we have 1, 4. And then I have 2 methyls, so it's di-methyl, no space, cyclohexane. Okay, all right. So here is one more. Go ahead and try this one. Thank you. Thanks so much. All right, are you ready to try this one? Okay, so tell me what we need to do first. Count the ring. Okay, and how did you count the ring?
I just started with 1, 2, 3.
Okay, 1, 2, 3, and let me just keep going. So we have 5 carbons in our ring. So what is the parent for that? Good. Pentane. All right. What did you do next? You want to lead us through it?
Sure. I think that was the easiest way to remember it, just because all 3 of them are on the list first.
Okay, perfect. Yes.
And then I started with chlorine because it comes first alphabetically.
Okay.
Alphabetically. Whoa, can't talk today. So I went 2-chloro dash 1, 3 dash cyclohexane.
And so this one's going to be just 1 carbon.
Yeah, methyl.
Good, methyl. So this one is just 1, so methyl. Good. And then cyclo. Let me see if we can get our eraser to work. Okay. Cyclopentane. Okay, good. Okay, so that's all for chapter 12. So you should be able to, after this, you should be able to get through all of the chapter 12. So today, we have about 45 minutes left. I would work on, if you haven't turned in lab 5, make sure you work on that. Then make sure you get the Alex chapter 12 done. Next time we come, we're gonna have pre-lab, you need to have pre-lab 34 done, so make sure you get that done, okay? Questions before we end? All right.